Alright, so in this video I'm going to talk about how to draw a Bohr model, how to know how many electrons, protons, and neutrons go where in the model, and specifically what energy levels you're going to show them. So a Bohr model is much like this diagram that's right here in the center, where you see the nucleus in the center and you have these rings around it. And the Bohr model said that each ring has a different energy level, and you can see this one's labeled as the first one has an energy level of 1, the second one has an energy level 2, 3, and 4, and each successive ring would have an increase in energy. And the other component is that in the center of the Bohr model is the nucleus, and let's go ahead and label that. The nucleus, we know, has both the protons and the neutrons, okay? In these rings, we have the electrons, as shown here. So when the electrons fill into these energy levels, these rings, these orbits, they fill in a specific way. And so Bohr has identified that the first energy level can hold a certain number of electrons, the second has a certain number that's different, and you're going to need to know and be able to figure out where the electrons fill depending on what element you're looking for. For instance, if we were doing carbon, we know that carbon has an atomic number of 6, and so it would have 6 protons. And if it's an atom, we would also know that it has 6 electrons. And looking at the mass for carbon, carbon's normal mass is a 12, so we would know that the number of neutrons would also be 6. Now I picked a really simple element because it illustrates where the particles go pretty well. If we were going to start drawing this Bohr model, we would have to have in our nucleus, we would need to be able to show that we have our 6 protons and our 6 neutrons. And I can't squeeze it into that red circle in the center there, but you would want to show that they were there. Then we need to show our electrons. So what I'm going to explain in the next couple of slides is that these 6 electrons would fill into this model not as just 6 floating around, but they would really be 2 electrons in this first ring, and then there would be 4 electrons. Each ring has a limit to how many electrons it can hold, and we will look at that in the next picture. This Bohr model is a more elaborate, more fully filled version of platinum. So platinum, if you look on the periodic table, platinum has 78 as its atomic number. We'll go ahead and write that out. Atomic number. And it has a mass for a normal isotope of 195. So to draw a Bohr model for this one, we would recognize that the atomic number is the same as the number of protons. And if it's an atom, it is also equal to the electrons. We don't have any indication that this is an ion, so we're going to go ahead and assume that the protons and the electrons are the same. The mass is telling us that our sum for our protons and our neutrons is 195. So you could take the math and you could say that the protons are 78, and we could then subtract 195 minus 78 and get the number of neutrons as 117. There are a lot of electrons in this Bohr model, as demonstrated in these circles. You can see that each ring has a different set of colors, and if you look at the key down here, the blue ones are the S, the green ones are the P, and the red ones are the D, which doesn't mean anything right now. We'll get So you need to be able to figure out what ring gets how many electrons. The first ring, the innermost ring, can only ever have 2 electrons. The second ring will have 8 electrons. So if you're doing an element that only needs 6 electrons, for instance, like carbon, you would put 2 in this first ring and then the other 4 in the second ring, and you would stop. If you need more than 10 electrons, you continue on. So it goes, the filling order and number goes 2, 8, 18. This one, fourth one, is 18 plus there's another 14, so this one becomes 32, and the fifth is also 32. Typically, I'm not going to ask you to draw a Bohr model for an element that needs electrons at a higher level, but you can find them online and figure out how they break up. All right, let's quickly solve these two examples. We're going to make Bohr models for the information that they've provided. So they've given me in the left one, the chlorine model, they've told me that the atomic mass is 35 and they've given me the atomic number is 17. So because the atomic number is 17, I know that I have 17 protons. My mass is 35, so I will take 35 minus the 17, and that tells me that I have 18 neutrons. The number of electrons in this image is going to also be 17 because I don't have any information telling me that it's an ion. So in my first ring, I'm going to put 2 electrons, and in my next ring, I'm going to put 8 electrons, and that gives me a total of 10, 2 plus 8. I need to have 7 more electrons in my third ring. So you can see that the 2 plus 8 plus 7 is the 17 electrons, and that is my Bohr model for chlorine. That happens to be an atom, and it's a regular, normal isotope. It's not anything weird. In the right-hand version, we have magnesium with a mass of 26 and the atomic number of 12. So I can go ahead and put my 12 protons in here. And I know that 26, which is the mass, minus the 12, tells me that I have 14 neutrons. Now this happens to be an isotope, so if you're looking at the periodic table, magnesium is not going to match the 26 that I've been given here. It says 24 on the periodic table, so something weird is going on, which means it's an isotope. It's just a different example. Nothing changes in how we approach it. So the electrons fill just like normal. We know that we need to have 12 electrons because we do not have a charge up here, so we're going to put in our first ring 2 electrons. In our second ring, we're going to put 8 electrons, and I still need 2 more electrons, so I will finish filling in my third ring. So that's how you do a Bohr model.